Yes, good morning. So in previous class we observed that the linear amplification of a transistor and the equivalent circuits of BJT transistors. Now in this class I would like to analyze CE amplifier, that is analysis of CE amplifier. Meaning is finding its input impedance, output impedance and the voltage gain. First of all, let us see the CE amplifier circuit. So this is the CE amplifier circuit. Here the transistor type is NPN transistor with CE configuration. That means the emitter is at ground potential, input is at the base, output from the collector. And the resistors R1 and R2 acts as a voltage divider network. Along with VCC, it acts as a biasing circuit. Therefore, this type of biasing is referred as voltage divider biasing. Whereas the resistor RC, known as the load resistor, are also called current limiting resistor. And a signal is coupled to the base of the transistor with the help of a coupling capacitor. This is called a coupling capacitor. Its purpose is to connect signal from the source to the base of the transistor. Here Vs is the AC signal source, its input internal resistance is Rs. That is the construction, and the function of each and every component in this circuit is the transistor is used for getting the amplification, R1 and R2 resistors along with the VCC acts as a biasing circuit. What for biasing circuit? To locate the operating point in the active region and also to stabilize that operating point in the same region throughout the operation of the amplifier. And the RC resistor called as a current limiting resistor or load resistor. Therefore, it protects our device BJT from the power supply VCC. And CC is called coupling capacitor. As I said, its action is to connect only AC component from the signal source to the base of the transistor, but not DC components. Because for the DC, the capacitor action is open circuit. And the purpose of VS is to apply the AC signal at the input of the transistor. Okay, this is simply the CE amplifier. Now, to calculate the input impedance and output impedance, the voltage gain of this amplifier circuit, first of all you need to convert this one into small signal model. Let us see the small signal equivalent circuit of this amplifier circuit is like this. At the beginning I am representing a transistor in the equivalent model, including the early effect. In the equivalent model, the base emitter junction represented by the resistor R pipe, output junction is represented with the current source. In terms of GM, its value is GM V pipe. Including the early effect indicates a resistor R0 is connected in parallel with this current source, right? After that, in the AC equivalent model, the DC sources are short circuited. That means VCC is connected to ground. That's why the resistor R1 comes in parallel with R2 and its connection is in between base and ground, because VCC is connected to ground. Okay, VCC comes to ground, that's why R1 comes in parallel with R2. After that, the input source as usual, Vs, its resistance, internal resistance Rs is connected like this. Similarly, since VCC is connected to ground, the resistor RC comes in between collector terminal to ground. Therefore, this is a small signal equivalent circuit for the transistor in CE amplifier. And assume the coupling capacitor acts as a short circuit, because for AC the short circuit action is, the capacitor action is short circuit, right? Here, this is the small signal equivalent circuit for the CE amplifier. Now it's the time to derive input impedance, output impedance and voltage gains. Input impedance or resistance, where it is, this dotted line indicates this is the location where the input impedance is measured. Okay, if you look the resistance here, if you look here, what happens? It represents a parallel resistive circuit, like one resistor is R1 parallel R2, another resistor is R5. Therefore, the input resistance is R1 parallel R2 parallel R5, right? Madam, let's see, the input resistance Ri is, you can written it as Ri equal to R1 parallel R2 parallel R5, right? And coming to voltage gain, how can you define the voltage gain? Its notation is AV. Voltage gain means output voltage divided by input voltage. In the circuit, what is output voltage? V0. The output voltage is V0. And what about the input voltage? Vs. So V0 divided by Vs is the voltage gain. So you can write it as V0 divided by Vs, where V0 is the output voltage is obtained like, so what is V0? V0 is the drop across a parallel resistors R0 and RC. Okay, so output side, see the diagram in your notes, or you have the diagram. At the output R0 parallel RC, the drop across that resistor is referred as the output voltage. How much current flows in that resistor? Gm V pi. Therefore, the drop is minus Gm V pi into R0 parallel RC, where the V pi is V pi. V pi means this is the voltage across the resistors at the input side, right? This is the voltage across the resistors at the input side, and it is given as, or it is derived as, with the source voltage. Okay, so assume at the input there are two resistors connected in series. One is Rs and another one is Ri. Actually Ri means a parallel connection of R1, R2 and R5. Okay, therefore in case of series connected circuit, the voltage formula directly you can write as applied voltage, that is Vs, into the resistance at which you have to find the voltage, that is Ri, divided by Ri plus Rs, total resistance. Okay, like that here you can write the V pi equation and substitute this equation 2 in equation 1. It becomes like this. Therefore, from that the voltage gain AV equal to V0 by Vs equal to minus Gm into R0 parallel RC into this part, numerator part, actually equal to Ri divided by Ri plus Rs. Clear? So like that you can derive the voltage gain for the CE amplifier from the equivalent circuit. Now output resistance. Output resistance is derived by assuming the Vs as 0. When Vs is 0, Gm V pi also 0. Gm V pi means this is a current source value. Current source value 0 means you can treat the current source as a open circuit. Therefore, the output resistance or the output network consists two resistors in parallel. One is small R0 and another one is RC. Therefore, the output resistance is R0 parallel RC. R0 parallel RC, that is the output resistance. So like that you can estimate the input resistance, voltage gain and output resistance. Right? This is analysis of CE amplifier. Right? Now let us solve one simple problem using this analysis. For that, consider same CE amplifier circuit with the component values like R1 is 93.7 kilo ohms, R2 value is 6.2, 6.3 kilo ohms, RS is 0.5 kilo ohms, RC is 6 kilo ohms, beta is 100, VB is 0.7 volts, early voltage is 100 volts, VCC is 12 volts. With this data, find out the voltage gain, input impedance and output impedance of CE amplifier. Okay. So first of all, you need to calculate the quiescent collector current and collector to emitter voltages. Based on the voltage divider biasing, the collector current, the quiescent collector current is obtained with the value 0.95 milliamperes, whereas VCEQ is 6.31 volts. Now it's the time to calculate R pi, GM and small r naught. You know R pi is beta Vt by ICQ. Using that equation, you can calculate the R pi value. It comes as 2.74 kilo ohms. GM is what is the formula for GM? ICQ by Vt. Therefore, the value is 36.5 milliamperes per volt, and small r naught is Va by ICQ, so that its value is 105 kilo ohms. Now the input resistance and gain and output resistance are calculated by using the above derived formulas, so that you can get the voltage gain is minus 163, input resistance is 1.87 kilo ohms and output resistance is 5.68 kilo ohms. You practice, let us take the calci and solve this problem. You may get these values. Okay, thank you. In the next class, you can see the analysis of same CE amplifier including the emitter resistor, right? Thank you.